26 from the Stewart Calculus chapter 2.8 asks us to find the derivative of 1 over the square root t using the Newton quotient or the definition of the derivative. So here I've set up the definition of the derivative in Newton quotient. So I'm first plugging in the t plus h into the function, and I have my square minus my square root t. This represents my y1. The h represents the run. So I want to first of all combine this into a ratio so I can deal with this h, and so I can free up some factor of h to cancel with that h. So I'm going to first of all take that h out of that complex fraction and make it 1 over h. And in the numerator, I'm going to get a common denominator here. So we end up with square root t minus square root t plus h all over the common denominator root t plus h times square root t. Now we can keep it separate like this, or I'm going to end up just putting it into one denominator because it's easier to keep track of for me. So at this point I need to get rid of this binomial radical, so I need to multiply it by its conjugate. And that will end up freeing up that h to be able to that h right there to cancel with a divide by h. So I'm going to multiply by root t plus square root t plus h and do that on the top and bottom. And multiplying that all out, I end up with a limit as h approaches 0. And this is going to become t minus t plus h. So square root of t squared minus the square root of t plus h all squared. That allows us to get rid of the square roots. In the denominator, I have my factor of h, which is going to cancel. And I'm going to keep this in factored form, but I'm just going to put this into one term. So t squared plus th, and then multiplying that by the denominator, the binomial denominator here, root t plus h. Okay, so we can see that the t's are going to cancel. I'm left with negative h. So I'm going to write that in. So limit as h approaches 0. This becomes negative h in the numerator. I have an h in the denominator. And this becomes t squared plus th. And then all in this denominator here, I get root t plus square root t plus h. And you have to be careful what you can combine and what you can't combine. I can combine radicals with multiplications, but I cannot combine anything with pluses in there. The plus really messes up my radical algebra. So these cancel, and at this point I can substitute in. So I'll write one more limit as h approaches 0, negative 1 over square root t squared plus th. Okay, the h is going to be 0, so that's just going to end up being t squared square root. And here I'm going to end up with square root plus square root t plus h. Again, this h is going to go to 0, so I can then combine those like terms. So as I apply the limit of h equals 0, so I get square root t squared plus 0 times square root t plus square root t plus 0. So that's just going to be 2 root t. Okay, so I simplify that out. Negative 1 t squared square root is t. Here I get 2 square root t's. Write it like that. Okay, and that I could leave my answer like that. If you want, you can rewrite it as 1/2 t to the power 3 over 2. So looking at this then, setting up the graph of this, if I were to do the graph of this, it looks like this. I've got my 1 over root t, so it's going to go up like that on the right hand side. Okay, and I can find some point t here, and I'm just finding some arbitrary point t plus h. Okay, this is root t. We have another point here, this is going to be, I'll write it over here, root t plus h, and then I've set up my slope formula based on those two coordinates.